demonstrate the R.R. Moore rotary fatigue machine. There's a lot of little bitty steps in doing this correctly. If you don't do them correctly, what you end up with is broken collets. These collets are very expensive. These collets are about $700 a piece if you actually buy them individually, but you can't buy them individually, so you spend $1,400 every time to get the collets replaced. So the first step in this machine is make sure that all the weight is off the bottom when you're setting this up. And they each have a slot in them, so you just slide it off of the piece right there. We'll just bring that off to the side. Okay? Now, next step is, I'll show you all the different parts in this thing. You've got a screw right here, and what this does is this is what actually screws into the back of the collet. And as you tighten up on this, it draws that collet into a tapered sleeve in the end of the bearing assembly, and it squeezes down onto the specimen. Okay? So in order to actually put this thing together, that in there, and then you simply start to pull that in like that. And as you screw that in, it'll get tighter and tighter. Now obviously we've got to put the specimen in, and you want to go until the specimen actually stops. And then you've got 2 wrenches. 2 wrenches go back here on this side. And then you want to tighten it up. Now if you'll notice, this one right here has a set screw in the end of it. That set screw is for tightening it up to the motor on the machine. So that particular shaft always has to be on this side of the machine. So now, take and tighten this. And by the way, you have to really tighten this thing. It should hurt your hands when you're tightening this thing. I'm going to move that set screw in just a little bit so that way I get the wrench around that flat. Okay. Now, my hands are nice and thoroughly red. It is kind of painful to tighten these things up tight enough. Now, next step. And by the way, in case you're wondering, this side is up. It has the little hole in it. So this one has already got a collet in it, so I don't have to find that and put it in there. It is tightened down right now, so I'm going to have to loosen it up in order to get that collet to relax enough. Okay. I'll slide this in this side. I'm going to tighten this one up exactly the same way. Okay. Now, when you're putting this onto the machine itself, pick them up both at the same time, and you slide it in just like that. Okay, and it should be able to move back and forth like this. Okay. Now, the next thing you have to do is you got to find that set screw, and you have to turn this until that flat is on top, and you want to make sure that set screw lines up exactly with that flat, and then roll it all the way as far to the back as it wants to go. Now that piece right there, the actual drive shaft on this, is a flexible piece, and I will get one out of the drawer in a second and show you what it actually looks like. And you want to make sure that set screw is on that flat and then tighten it down on there. If you don't, you can damage that drive shaft. I don't know how much the drive shafts cost. We have one extra one. Let me grab it out of the drawer over here. This is what the drive shaft actually looks like. You can see it's got a slot cut in it in a spiral in motion, so it is very flexible. It also means it can be very delicate. So you don't want to take and break that. Just make sure you do all this stuff in the correct order. Now, next thing you got to do, there's 2 pins. These pins keep this thing from rolling too far back and forth this way, because if you get it to roll too much, it'll simply stretch this thing too far and then it'll eventually break it. We want this to fatigue, not this. Okay, so now this thing is in, the set screws are done right here, everything is upright. There's nothing that goes on this end right here. The next thing you have to do is you have to load the weight onto it. And you do that by simply taking these 2 little pointed pieces right here and putting them on this. Okay. Now obviously at the very beginning we took off all the weight that was on the arm, so we're not going to have an issue with that at this point in time. And the machine is now set up. Now there's some switches on here that most people don't really know about. The one on the side right here on the right is the one that most people forget. And then you've got a reset button there. And this one right here is the one that actually turns it on. Okay. Now it's going to vibrate some. Everything that spins has some kind of natural frequency vibration, and it's going to do that. But you'll get to points where it actually smooths out really, really nicely. And if you look over here, this right here is actually your RPM meter, and that will tell you how many times it's spun around. So you can set the speed on it right here, and then use this to just turn it on and off. But you just got to remember to hit the main power switch over here. And that's the mistake that most people make whenever they're setting this up. Now, in the past, the weight that we typically use on this is about 22 pounds to make it break about a 2 to 3 minute window, something like that. So what we're going to do is we're going to get all the weight situated. That's a 5-pound block. We've got, here's a 10. Figure out everything we're going to put on it. And then I've got a 1 pound, and there's a 2 pound. So these are the 3 weights I'm going to put on it. I'm going to go ahead and hit the reset button on that right there. I'm going to set this thing at about 50% of its maximum RPMs, which I don't know the maximum RPMs. I think it's around 10,000, 11,000, something like that. So I'm going to set it on 50%. Like I said, we don't actually know what it is. Now, then I'm going to turn it on. Okay? And what I want to do is I want to put the weight on here. And this is the part that's kind of challenging. Because as soon as the weight goes on it, I want to hit the reset button. Okay. So now we have the machine spinning. And it should take around, I think it's 2 minutes or so. By the way, this is the easy part of running the machine, is loading it up. The hard part is actually taking the specimen back out. So that's actually the biggest problem that most people have, is actually get the specimen back out. And you're going to notice that it's going to change sounds. We're at about a minute, 2 minutes, 15 roughly. And then I'll take this and hold it out. It means like 2.5 minutes. Right now it has spun, just hit 12,000 revolutions. It has spun. I don't remember how many revolutions it takes on this particular piece. I want to say it's 20,000. Roughly. 22,000, something like that. It was right at 3 minutes. Okay. Now you got a final count on how many RPMs it made it. It automatically turns off whenever it figures out that it has broke, so you don't have to worry about it sitting there. Just keep it on spinning. Okay, now for the hard part. Taking the specimens out. And first thing I do is unload each one of the bearing carriers. Pull that off there. Okay. Now obviously I can't pull this out until I loosen up the drive shaft. Okay. Now the drive shaft is loose. I'm going to take the 2 pins out. Pull that out that way. Now, next step, I have to loosen each one of these pieces. Very important that you get the direction correct, which way to loosen it. Righty-tighty, lefty-loosey, if you don't know the saying. Okay, now the first thing you notice, it is now loose, but this is still tight in there. And the reason for that is because it's a collet that has been squeezed up into a tapered surface. So it doesn't want to let go of that very readily. So as soon as you loosen it up, you need to back it off about 1.5 turns on this. Take a rubber mallet and you hit this end. Okay? Now if you do everything just right, then with one hit you can pop the thing loose. Do the same thing for the other one. Make sure it set screws not in the way of the wrench. Now, something to note, it is extremely important that you do not back this out too far. And I'll show you exactly what happens if you do. I'll just show you. If you back it out too far, what ends up happening is you end up hammering just the tips of the threads, and it ends up damaging the collet and this piece right here. So by just backing it out just a little bit, what ends up happening is, back it out just like that, the threads are much more fully engaged inside the collet, and therefore it protects the overall structure on the inside of it. You don't have an issue with stripping threads out. Okay, and it is ready for the next specimen. The only thing you have to do is take the next specimen and you just start over on the whole process. Like I said, the hard part is getting the hammer hit right, where you actually loosen these up and get them back out without damaging anything or without hitting yourself in the wrist or something like that. So, and that's the full demo on how to use the RR Moore fatigue tester.